Newton's second law of motion states that the acceleration of an object depends on the net force acting on it and its mass. This can be written as F equals ma, where F is the force, m is the mass, and a is the acceleration of the object. When I let go of the car, gravity applies a force pulling it down the ramp. Since there's no engine in the toy car, the acceleration depends only on the steepness of the ramp and the force of the gravity. I've now increased the angle of the ramp, making it more steep. This also increases the force of gravity acting on the ramp, which makes the car accelerate more. A greater force leads to greater acceleration, just like Newton's second law predicts. But what happens if I use a heavier car? Since Newton's law states that F equals ma, an object with more mass requires a greater force to achieve the same acceleration. Well, in this case, gravity increases the force, so both heavy and light cars accelerate at the same rate. Now, when the car moves up the second ramp, gravity applies a force in the opposite direction, which slows the car down. This shows how force and acceleration are directly connected. When the force is against motion, acceleration decreases and the car will eventually stop. So, Newton's second law helps us understand how force and mass affect acceleration. Whether it's a car on a ramp or a real vehicle on the road, the same physics apply.